Welcome, Hornets, and thank you for joining me for this video. In this video, I'm going to be taking a look at the tangents and how do we use an arctangent in order to solve a tangent function. So, a couple of things to be aware of. Let's start off with what a tangent looks like. A tangent has asymptotes in its repeated periods, and they look like cubics in between the two asymptotes. Comes down and then goes up. So if I'm looking at my arc, the arc is going to have a horizontal limit. Once again, if this is pi over 2 and negative pi over 2, I have a negative pi over 2 crossing this way and a positive pi over 2 crossing this way. Our tangent arc is then going to look like that. And you'll notice it only has in between these two values, pi over 2 and negative pi over 2. Well, that means that the calculator, when we try to solve it, will only give me an answer in the first quadrant, and then will give me the opposite of the answer in the fourth quadrant, just like sine, which means that we're going to have the same issue that we had with sine, but we have to now work with the tangent in the first and the third versus the second and the fourth. It will only give us an answer in the first, and any other answer we're going to have to locate. This will require us to use our reference triangles, so we do have to be careful. Let's go ahead and start with the tangent that's positive. So let's say we have the tangent of theta is a positive 11.4213. We're going to use the arctangent, so theta equals the arctangent of 11.4213. Since our calculator is in degree mode, we're going to go ahead and we're going to punch it in exactly as we see it. So I have second function tangent of 11.4213. Closing my parenthesis, I'm going to get the angle. Notice this angle is in the first quadrant. Therefore, it is the reference angle. In order to find the next value or the second solution, remember this is my first solution, and this is approximately 84.9961 degrees. To find the second solution, all I have to do is add 180. It's already a positive reference angle, and in the third quadrant, it's 180 plus theta prime. So by adding 180, we get our second solution, 264.9961 degrees. And we're done. Let's go ahead and do another one. Let's take the tangent of theta is going to be 2.4448. We start with the arctangent, so the arctan of 2.4448. We hit second function tangent in our calculator. We put in 2.4448, close and hit enter. There is our reference angle. Notice it's in the first quadrant. In the first quadrant, the angle is the reference angle. It is also our first solution, 67.7538 degrees. And you can either round or truncate. To find the second angle, we add 180 to it, and we get our second answer, theta 2, is approximately 247.7538 degrees. That's the way it works. Tangent with a positive is pretty straightforward. Let's take a look at tangent with a negative now. Let's say we have the tangent of theta is negative let's do 8.0 0.0354. So once again, we're looking at a negative 8. I got a little bizarre there. That means that my theta has to equal the arc tangent of 8.0354. We're going to put it into our calculator. Second tangent, 8.0354. Now we're going to get an answer that's between negative 90 degrees and 0. Once again, it's the opposite of the first quadrant. It will be the opposite of the reference angle we want to use. And we can find our first value in the fourth quadrant simply by adding 360. That'll give me 360 plus a negative reference angle. Okay, I didn't put my negative in. Let's try that again. It was supposed to be a negative, and I forgot that negative. So I'm going to just repeat it and put a negative in. Insert a negative. And there we go. Now we get our negative answer, negative 82.9060. By simply adding 360 to this, I get the coterminal in the fourth quadrant, and that coterminal is the first solution, approximately 277.0939 degrees. To find your second solution, if this is my fourth quadrant, all I need to do is go 180 degrees. So I want the opposite ray. I want to get a straight angle with it. And so all I'm going to do is subtract 180. I now have my answer in the second quadrant, and that's going to be 97.0939 degrees. So notice, that wasn't so bad. If I have a positive tangent, I add 180 degrees to it. But if I have a negative tangent ratio and I use my arc, I get a negative reference angle, and so I add 360, and then I subtract 180 to get the second answer. Let's do another one. Let's do the tangent of theta, and this will be approximately, let's do, negative 27.5581. Alrighty, we're going to have to start by making the arc. So we do theta is equal to the arc tangent of this negative 27.5581. We're going to put it into our calculator now, exactly as we see it. So I have second tangent, that's the arc tan, negative 27.5581, close, I get my answer. There is the negative reference angle. So if I add 360, I get the first answer, and this is in my fourth quadrant, 272.0781 degrees. By subtracting 180, I get the second answer in the second quadrant, and it is 92.0781 degrees. That's working with our arc tangents in our finding our solutions. I hope this has helped. If you liked this video and it has helped you, please click like, and if you have suggestions or comments, please feel free to offer them. Just a reminder, I hope you all have a very safe and good weekend. In the next video, we'll be taking a look at how do we use our calculator in order to find arc secant, arc cosecant, and arc cotangent. Thank you very much. Take care, be well, and be safe. Bye-bye now.